All right, welcome to part 3. We're going to go over problems 21 to 30 of your semester 1 final review. Now we're looking at functions, so we're looking at which one represents a function. Remember that in a function, every input has exactly one output, which means that we only care about our domains, which are our x values. We do not want any duplicates. So 1 is a function, 2 is not because I have 2 3's there, and 3 is a function, so C is our answer. All right, looking at functions on a graph, if you remember, we had our vertical line test, so we're looking to see if there are 2 spots that hit our vertical line, which means that our x input would have 2 outputs. So as I drag this ruler across, you can see that on graph B, I'm only touching in 1 spot. In graph A, though, I start touching in 2 spots. So I touch here and here, which means that A is not a function. We can do the same to our other graphs on here. C and D only touch my ruler in 1 spot. They are functions. So my answer to this one is A is not a function. All right, we have Kaj here needs to build 15 birdhouses for a class project. It takes 20 minutes to build each birdhouse. The number of minutes that it takes Kaj to build birdhouses is a function of the number of birdhouses she builds. Which statement correctly describes the domain or range of this function? So we're looking for one answer here. So I kind of drew out over here a little example of what was happening, that it takes 20 minutes for 15 birdhouses. 15 is my domain. That's what's going to go in there. She needs to build 15, so they might build less or more. And the range is the total hours. So because we're building birdhouses, we cannot have the domain or the range be all real numbers, because we can't have a negative amount of birdhouses and I can't have a decimal amount of birdhouses. The domain being all numbers from 0 to 15 seems correct because they told us that she needs 15 birdhouses. The range being all integers from 0 to 300 could be correct, but because it tells us the 15 and it doesn't tell us necessarily the range, we're going to go with B on this one. All right, number 24, we're just having a function here, h of x, and then we have an equation, and we want to find out what happens if h of x is actually h of negative 29. So all I did was replace x with negative 29 and solve, and I got 35 halves. For number 25, we have a point, negative 12n is in the ordered pair of the function f of x equals 3x minus 9, and we need to find the value of n. Because this is an ordered pair, we can correctly assume that negative 12 is x and n would be representative of y. Because our function is in the same format as our linear function in slope-intercept form, we can assume that f of x, the answer, is the same as y. So what it's really asking is, when it asks for the value of n, is what's the value of y. So all I'm going to do is replace x with a negative 12, solve, and I get negative 45c. For number 26, we have a cell phone company charging a monthly fee of $45 for a single phone line and $15 for every gigabyte of data used that month. Write a function that models the total monthly cost of the cell phone line. Well, we're going to say that the monthly fee is our initial value, okay, because that's getting charged just monthly, whereas our $15 is for every gigabyte used, so that's our rate. We're going to multiply 15 by every gigabyte. So our formula is going to be 45 for that monthly fee plus 15 for every gigabyte, D. Number 27 is saying that the graph below represents the total amount of profit in dollars a company expects to make from selling bracelets. According to this model, how much money would the company make if they sell 400 bracelets? Round your answer to the nearest dollar if necessary. Now, if I look at my graph, you can tell that we do not go all the way up to 400 bracelets. There's no way that we can go up to 400 bracelets. That means I'm going to have to use some estimation by making a function, or not estimation, but I'm going to have to use a function to predict how much they would make if they sold 400 bracelets. In order to make that function, I need to write in a function for this graph. So my y-intercept looks as though it is negative 6. So in my formula, y, or if I was doing a function, f of x, equals mx plus b, my b is going to be negative 6. Okay. I am then going to look for another point like this one here, and I'm going to calculate my slope. Okay. 1, 2, 3, 4, 5. So this is a rise of 5. And then my slope, my run is 2. This is a positive slope as it increases from left to right. So my slope is 5 over 2. Okay, I can double check my slope by finding a secondary point on here and just double checking that I did it correctly. 1, 2, 3, 4, 5. 1, 2. That is the correct slope. Therefore, my y-intercept and my slope are correct. The next thing I'm going to do is now take my input of 400 and put it in for x, my domain. I'm going to say that 5 halves, sorry for all the glitching. Let's see if it figures itself out. Not quite. Let's do it a little lower. 5 halves times 400 minus 6 is going to be my total cost. Okay. If I multiply this here, I've got 5 times 4, which is 20. So that's 2,000 divided by 2 minus 6. That's going to end up being 1,000 minus 6. So I'm going to put my answer over here to the right. 1,000 take away 6 is going to be 994. That is going to be my answer for the price made. That's how much money. A. For number 28, we have an apple orchard allows people to come and pick their own apples. Customers pay $5 for a basket and 10 cents for each apple. This is the function that represents the cost x for x apples picked. We want to know the range of the function. Remember that your range is going to be y, your y value. It cannot be all real numbers, okay? Because again, we can't have negatives and I can't have increments that are not for what I'm going to buy. When I go and buy these apples, I can only pay $5 for the basket and then 10 cents for each apple. If I only buy a basket, I'm going to pay $5. If I buy a basket and 1 apple, I'm going to buy, say, 10, 5, 10, 2 apples, 3 apples, etc. D is the correct answer because these are the only increments of numbers that I can buy apples in. I cannot buy just 10 cents of apples because you're going to need a basket to pick your own apples. Okay. And I can't just have whole numbers because every apple costs 10 cents. All right, 29, we're going to go ahead and describe the relationship and the correlation in the scatter plot. We've got women's winning times in marathons. Our y-axis is times in minutes, and our x-axis is years. The correct answer here is D, because as the years, which is x, increases, as the years go up, the winning times decrease. Okay, we're going down. All right, we're on our last question for this video, which is 30, and we're looking at the best trend line or the best line of fit for the scatter plot. Now, because we have a multiple choice option, what I would do is actually graph every single one of these lines, or at least attempt to graph each line and see which one makes the most sense. I would probably start with my y-intercepts because then I can start eliminating answer choices. So my first one would be a positive 8, which would be way off my chart. So I can tell that A is not going to be a best line of fit. Negative 3 is going to be way below. So I'm also going to say B is not my best line of fit. Both C and D have a y-intercept of 3, which would put me right about here. And that makes sense, although my dot glitched on me. Here, let me switch pens really quick. All right, so... and so then C is going to be a positive 3, and then D is going to have a slope of 3, so I'm going to go up 3 and over 1. And as you can see right there, that yellow line is not a very good line of fit. So I would say D by default is not the correct answer. So let's just triple check. I'm going to change my color here. And I'll show you that if I start at positive 3 and I go up 2 and over 3, so 1, 2, 1, 2, 3, that is going to have a much better line of fit than any of my other options. So I would say our best bet is C. Ooh.